So we have the angle, addition, postulate, supplementary angles, complementary angles, and vertical angles, supplement theorem, complement theorem. You were supposed to have read all those. Do you have questions about any of those portions of the angle relationships?
Question, what is that little thing in the middle of the screen?
That's the cursor.
Okay.
Okay? At the bottom there's a couple of examples. Example 1, we're finding the measure of angle 3, 4, and 5 if measure of angle 3 is given, 4 is given, and 5 is given as those relationships. As you look at your figure for this particular problem, now, we are told that the measure of angle 3 is x plus 20. The measure of angle 4 is x plus 40. And the measure of angle 5 is equal to x plus 30. Based on the information above, those different theorems, what can we do to help us find the measure of angle 3, 4, and 5? Okay?
Well, it looks like since angles 3, 4, and 5 are all on one straight line, that means all of them together equal 180 degrees. So the measures of all three angles added together is 180 degrees.
Okay.
So then if the measure of angle 3 is x plus 20, and the measure of angle 4 is x plus 40, and the measure of angle 5 is x plus 30, then x plus 20 plus x plus 30, then x plus 40 equals 180.
Slow down for a second. First question I have for everybody, do you understand what the thought process is behind this? Okay, I got a couple of head nods. Everybody got that? You see how those pieces fit? Okay. And so now we do some algebra here. You collected like terms. Did you end up with somewhere saying the 3x plus 90 equals 180? And so x is equal to, is that 30? Did you need to see any more algebra steps to get to that point? Okay, so now that you have x is 30, what are you going to tell me? Okay?
Plug it in.
Plug it in. Where?
You plug it into the angles that you need.
Okay, so you're telling me then that the measure of angle 3 is how many degrees?
50.
50
degrees.
Measure of angle 4 is how many degrees?
70.
60.
60.
Okay? Do we agree? Okay? Number 2 says if 6 and 7 are a linear pair, measure of angle 6 is 3x plus 32, measure of angle 7 is 5x plus 12, find x, 6, and 7. So what did you write as your equation? Tell your neighbor what you wrote as your equation for that one.
Uh-oh. I messed up. I messed up.
I know.
I did 8x plus 44 and 180.
I messed up.
What?
I just thought
All right.
there's not a lot of
I didn't finish it.
Eyes back up here. So you have measure of angle 6 plus measure of angle 7. Because they're a linear pair, they have to equal 180. You create this. 8x plus 44 equals 180. So 8x is equal to 136. And x is equal to... let's see, 17?
Yeah.
Okay. And then 3 17s and 32 is 83. Is that right?
Yeah.
And 5x and 12, or 5 17s and 12 is 97?
Yeah.
Is that pretty good?
Yeah.
You agree? Matter? Okay, this is a lot of practice.
I just want to stand.
Alright, we keep going. The next page has reflexive property, symmetric property, and transitive property. Now they're listing them here. We've used them already. Any questions about those three properties? Okay, then there's three theorems. Theorem 2.6, 2.7, and 2.8. Theorem 2.6, angles supplementary to the same angle or two congruent angles are congruent. Yeah, okay, what's that mean? Uh-oh.
Wait, no, that's a tongue twister.
Theorem 2.6.
Kind of like a linear pair, but not connected.
If I have an angle here, such as, this is angle 1, and we have another angle here, which is angle 2, and we say that the measurement of angle 1 plus the measurement of angle 2 equals 180. So these are supplementary angles. Okay? But then let's say we also have another angle right here. It's angle 3. And we discover that the measure of angle 2 plus the measure of angle 3 equals 180. Can you tell me anything about measure of angle 1 and measure of angle 3? Jack?
Well, they have to be congruent because the measure of angle 2 isn't changing to be congruent with angle 3.
Yeah. So in other words, this is a similar part. So these two have to match. So your theorem is just allowing you to skip all the math you have to do to get there. And it says, oh, this is always going to be true. Yes, Lonnie? It's a little bit like that transitive property, yes. So it's utilizing that kind of property. That's a theorem. It's been proven. It's not that hard to prove either. It's kind of fun to do. But I'll leave that for you to do on your own. I don't want to take that fun away from you.
No fun taken away.
Theorem 2.7. Angles complementary to the same angle or two congruent angles are congruent. What's the difference between Theorem 2.6 and 2.7?
They're
Complementary instead of supplementary.
Anything else different? No. So it's basically the same thing. Theorem 2.8. If two angles are vertical, then they are congruent. Did we use that this morning in Bellworth?
Yeah.
Okay. See, I was hoping you had read this to see that. Why I did that problem. If two angles, or if angle 2 and 4 are vertical angles, measure 2 is given, measure 4 is given, find the measures. How do you set up that equation? I know you got an answer for me. I want somebody else. Shelby?
6x plus 2 plus 8x minus 14 equals... Sorry.
If angle 2 and angle 4 are vertical, that means in our minds we need to say what?
Angle 2 and angle 4 equals each other.
So measure of angle 2 equals measure of angle 4. You need to say that in your mind when you see that they're vertical. Okay. Pearson?
That would be 6x plus 2 is equal to 8x minus 14.
Oh.
Okay. So x is equal to 8.
That was...
But that's not the answer we wanted though, is it?
Nope.
Okay. Hey guys, something I've noticed in grading some of your homework, some of you are doing a really good job. You get to X and then you think you're done. We're not always done. I hate to tell you this, but that holds true throughout the rest of your math career. My students in calculus, they'll get to an X and they think they might be done, and I go, no, we got more work to do. Just smile at them, they grow. It doesn't change. So when you get to an X, we're not done. The measure of angle 2, we want that answer. So we want 6/8 plus 2, that's 50, right?
Yes.
Well, are we going to have to work really hard to get to the measure of angle 4?
Nope.
No, I hope not. They're equal, they got to be equal. Now, instead of just writing that, should I check and say that 8 times 8 is 64 minus 14, that is 50? Should I really do that math?
Yeah.
On the test, I probably ought to. That checks it. That really makes sure that what I think is true is actually true. That's a good way to do that. All right. The next example, if angle 6 and 8 are complementary, then and 8 equals 47, find the measure of angle 6, measure of angle 7, measure of angle 8.
What?
What does it mean for angles to be complementary?
90.
Equal.
Yes, they do. So if they equal 90, and I know that one of them is 47, what's the other one got to be?
43.
Yeah, because 47, 43 makes 90. And then you know two of those angles. Okay. If you know two of them happen to be 90, and you know combined three of them make 180, what's the third one have to be?
90.
Okay. I hope you did that without necessarily doing a lot of subtraction.
You didn't.
Nope.
Hope you did that by a process of logic. Please understand that we're trying to gain some steps and save ourselves some math steps in the process. Questions about that?